Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live, with a bit of a surprise webcast tonight, tracking BepiColombo, the European Space Agency, and actually I think it's a joint mission between ESA and JAXA to the planet Mercury. So it's should just now be rising out of the trees. Still dealing with some foreground trees, so I'm gonna try to see what I can do here. Crank up the exposure. Let's do a 1-minute expose. These are gonna be 2x2 bend images to increase sensitivity, at least until we get out of the trees. That will mean that these are grayscale images and lower in resolution, but hopefully with increased sensitivity. So welcome to the stream. Sorry, I got a bit of a late start tonight. Yep, stream is live. Okay, good. So, yeah, I had been thinking that I was going to have bad weather tonight. The forecast called for clouds, and it's clear. It's been clear since I went to bed. Got some sleep and then got back up and set up the scope. It is extremely muggy though. The humidity is unbelievable, and I got to give myself a little slap on the hand for not changing the desiccant on this camera, unfortunately, so I can't cool it down to sub-zero temperatures because it will freeze up immediately. So I am tracking it here with NeoTracker. I'm gonna load up JPL right here and check on the coordinates that we're tracking. So the scope is tracking based on the expected orbital elements of the probe, which is currently flying by Earth for a gravity assist on its way to Mercury. It's quite close to Earth right now, so I'm thinking I should be able to detect it at least once it gets out of the trees if I'm pointed in the right direction. So I'm going to verify some things now, just make sure we're all on the same page, the scope and myself. So we are currently 18 minutes after the hour. At the risk of ruining this picture, I'm going to bring up the coordinates display. Oh, hi. Yeah, I'm seeing quite significant difference between where I thought the scope would be pointed and where it is pointed. There might be some issue there. Let me I can correct it though. I just need to see what the delta should be. could be that the package I'm using to calculate the orbit isn't quite accurate enough for this high-speed probe. Could also be that because I'm not using my exact location to avoid doxing myself, my calculation's a little off. Either way, I should be able to fix it. Currently 19 minutes after the hour, and we are, oh man, we're about 38 arc minutes. Oof, okay. Alright. Assuming this has got to be, because these are apparent coordinates, these have to be at the epoch of date, right? Yeah, that's all cute and everything, but let me just verify I'm getting the... Doesn't really say. I'm assuming it is. I'm gonna go with that assumption. What are we now? We're 20 minutes after the hour. Okay, so 20 minutes after the hour, I'm expecting that to be about 6 times 15. 90. Jeez, I'm expecting about 90 arc minutes. Nope. 90 times 60. 5,400 arc seconds. I can't type. Okay. What are we now? We are 21 minutes after the hour. Yeah, that's better. Maybe not quite that much. Okay, that's good. Now this needs to be, what are we, 22 minutes after the hour. 28, 25, 28. So I'm expecting that to be about 50. What's 50 times 60? 3,000 arc seconds lower. No, wrong? Oh, no, 3,000 arc seconds higher. Wrong sign. Okay, try that. Okay, this is now, we are now 23 minutes after the hour. Yep. We're pretty close to where I expected us to be. Here we go. Instead of a full minute exposure, let's do 15 seconds. We are 23 minutes past the hour. Okay. We are 24 minutes past the hour. This is really tricky trying to get it. Come on, baby, come on back. I hear it moving, but I'm not seeing 24 minutes. Okay. Yeah, that's better, I think. So 25 minutes, we should be 49. We should be down to Of course, the trouble is, let's see if JPL describes equator of date. Yeah, so this is equinox of date. These coordinates should be good that I'm using here to compare. 26 minutes past the hour. I feel like something is very wrong with these calculations that it's doing, because we should be descending in right ascension faster than we are. This thing's moving at a pretty good rate. Okay. What are we, 26? Well, no, okay, that's the wrong way. Okay, I wish I had actually been able to set up my... Hey, why is my, that's not good. In my rush to get set up, I neglected to plug in the laptop that's doing the broadcast. Alright, now it's plugged in. So, okay. Where are we now? We are 28 minutes past the hour. Okay, we are still too high in right ascension. It keeps going too high in right ascension. It's better-ish. 23:43. We should be a little bit lower. And at 30 minutes past the hour, we should be at -23:09. It's pretty close. Oh, good. I've also got itelescope.net. I've got some scopes lined up that should be taking pictures too. So even if I'm having too much trouble here, it should streak through the view of some of my telescopes that I'm set up to go. Gosh, alright. Alright, I'm going to try another strategy here instead of direct tracking, which honestly should have worked just fine, but it's giving me some grief. Alright, so I'm going to... We are at 29 minutes past the hour still. I'm going to move ahead to where it will be in about 3 minutes. And I'm going to plug in those coordinates directly. 12:28:05, negative 22:36:37. Negative 22:36:37. Okay. So this should pass through the center of the view in about, well, less than 60 seconds. Come on. It's going to be hard to do, though, if it's just rapidly streaking through the view. Right about now. Is when it's predicted to. Okay. It's really tough. Really tough. If it's moving too fast, then if it's too faint, it won't be detected this way. So direct tracking does have the better chance of working, but it's at peak altitude now, 38 degrees over the horizon. Okay, we are now at 33 minutes after the hour. It will have moved on. So let's go back to direct tracking, try it that way again. Gosh, it's lingering too high in right ascension for some reason. That's goofy. $34? 34. Okay, we're already at 34. Should be down to 45. Five minutes after the hour. Gosh, I should be right on target. 36 is when it transits. Pretty much right on target. Should be 17. Oh, we got it. I think we got it. There it is, right there. I betcha that's it. Sweet. Yeah, BepiColombo. Top left of the image. Just had to get it dialed in. What a pain, but finally got there. She's moving up and out. Let me drop it in. See, the tracking's not perfect. It's drifting a bit for some weird reason. Could be due to Earth's gravity, maybe? Alright, I'm going to try to move it right in the view next. Okay, that's helping. Good direction, good direction. Give it a little more. And try to move her to the right. Okay, that's good. Let's give it some more. mean, it's also possible that I'm running off JPL's prediction for the orbit of the probe, and maybe their elements aren't quite as up-to-date as getting it direct from ESA. I don't know, just a thought. Okay, cool. Cool. We got ourselves a space probe. I'm so happy. It's supposed to be about 9 apparent magnitude, according to the Italian website. Well, that looks about right. That's a little bright there. All right, we can actually go down to a much shorter exposure as a result of that. I'm gonna change this to see on it. Reset the count to 0. Let's go down to 1 second exposures and go. Go. There we go. Alright, we have BepiColombo in view. I'm pretty sure. Yeah. Yeah, it's gotta be. Because it's moving 1 degree in azimuth per minute, roughly. A little more than a degree per minute in azimuth. If this were like a geostationary satellite, it'd be zipping out of the view a lot faster than this. It's drifting out a little bit, because for something's not quite right with my tracking, for sure. It's not following the coordinates as tightly as I would have expected, according to JPL Horizons. But my program does not account for Earth's gravity. It's just running off of static orbital elements. So I think it could be that is a factor. Because it is receiving a gravity assist from Earth right now, which is bending the trajectory. So I guess future update. I will work on trying to be able to account for a planet's gravity in Neo Tracker. Do real-time updates to the elements and that kind of thing. That would be cool. Alright, let's drop it. What do we need here? Which is the good direction to do? Okay, that's the good direction. Okay, so they said apparent magnitude 9. Yeah, that's visible in amateur telescopes pretty easily, which is why I'm able to do 1 second exposures, and this thing's showing up just fine. Very dramatically bending the trajectory. Exactly. So quite a challenging object for Neo Tracker to track. Normally, it's tracking near-Earth objects that are considerably further. So right now, T20 on itelescope.net in New Mexico is starting a run to take pictures of it. So I should be able to get parallax from New Mexico and Florida simultaneously. Sweet. But I actually don't know how easily these images will solve astrometrically. The star streaks are pretty faint at 1 second exposure, and this thing's moving pretty fast. I don't really want to go down to 3x3 binning. I mean, I could. That would increase sensitivity and all of that, but at the expense of resolution and all of that, it would not make for as nice a stream. So I'm going to sacrifice the ability to potentially astrometrically solve these images in exchange for sensitivity. I'm also trying to set up telescopes, the telescopes in New Mexico, to not only take pictures of it, but also a telescope in California, because that was my plan B, was to get parallax from California and New Mexico with simultaneous observations. Really tricky to do, though. I was trying to schedule it around other people's already planned observations and get 2 telescopes, one in New Mexico, one in California, to look at it at the same time. I did find a slot where that's theoretically possible, but it's pretty close to the limits of the telescope in California's ability to point. Just pointing limits. So, and also, I don't know, I mean, I've struggled with finding it initially, so, you know, if part of the issue is that JPL's coordinates are out of date, then this just isn't going to work in New Mexico anyway. Certainly not with the big scopes over there in California. The big scope in California has got a pretty narrow field of view, about the same that we're dealing with right here. So you have to be on it. You have to be pretty accurate. Right now, a wide field telescope is taking shots of it in New Mexico, so that's got a better chance of working. But with only like 3 star streaks going through here, that's not enough. That's not enough to astrometrically solve and really determine decisively what the coordinates are that we're actually at. I mean, I can bring up this window, but this is approximate right here, the coordinates that are being sent to the telescope. I mean, I could pull that and just say, okay, well, that's what we're at, but that's not going to be as high accuracy as doing proper astrometry. But nevertheless, it's fun. We're tracking the probe as it makes its way towards Mercury. Seems like, I don't know if it's getting, no, I don't think it's getting dimmer. It's just my imagination there for a moment. But yeah, it's going to start descending pretty quick. It's already transited the highest point it's going to reach in the sky, and it's going to start descending. I'll probably be able to have it, oh, actually, wow, we're already at 47 after the hour? Wow, it's already, if that's the case, we're already at 23 degrees over horizon. We're already getting pretty low in the sky. It's going to transit my local sky here pretty quick, to the point that I can't track it anymore. No more than, I'd say, probably 30 minutes is the maximum amount of time I'm going to be able to get out of it. Maybe less. It might go into a tree pretty quickly. But hey, we got it. We captured it. We tracked it. How cool. How cool. Thank you, NeoTracker. Couldn't have done it without NeoTracker, that's for sure. Granted, I'm having to compensate for the fact NeoTracker is not accounting for Earth's gravity in the motion of this probe, but even with that limitation, it's still, you know, it's still getting it in there, keeping it in there reasonably well. I mean, you can see how quickly the stars are streaking. So, you know, if I wasn't tracking the stars accurately, or if I was tracking the stars and not tracking the probe even somewhat close to accurate, it would move through the field of view pretty quickly. Yeah, exactly, Eric Briggs. Orbital elements are not accurate enough because of gravity assist. State vectors should work fine. Yeah, that's where I need to get to, honestly, is instead of NeoTracker working off of elements, I mean, it can work off of elements, but it needs to convert them to state vectors at the epoch of the elements, and then run off state vectors and update them based on gravity. Basically, I guess I need to build my own numerical integrator in Python. I'm sure somebody's already done that. Somebody has had to have done that. So maybe I'll look around on GitHub or wherever and see if anyone else has built a numerical integrator. There's probably a Python package out there for it. You might know of one, Eric. If you know of one, recommend it to me, and I'll take a look. So I haven't actually read up on Bepi's mission all that accurately, and I apologize if I'm butchering the name. So I'm assuming it is going to make a map of Mercury. It's a mission to Mercury, and I honestly have not had time to read up on it all that much. But somebody mentioned in the chat a night or two ago during one of my Comet streams that Bepi was going to be flying by Earth. I had forgotten about that. So one of my viewers, I wish I could remember who, recommended that I track it. So whoever you are, thank you. If you're in the chat tonight, say hi. So this is a viewer recommended stream right here. Move it back a little more. You use Mathematica's ND solve. Tons of integrators available. Yeah, I agree. Yeah, why reinvent the wheel, right? I knew somebody has already done that. I just want a Python implementation. I don't know what would be the best to do. Is there a way to interface Mathematica with Python? I don't know. I'm not familiar with that. Way over your head, Eric. Yeah, that might have been you. Well, if it is, thank you. Appreciate it, because this is cool. This is really cool to be able to do this. I don't get to crack NeoTracker open that often and use it. Mostly use it. It's really best for fast-moving objects close to Earth, very close to Earth, like this one. It does have the issue of, not dynamically updating the orbit, but still, the encoders on this telescope work best when tracking high-speed objects. If it's a real slow-moving comet or a real slow-moving asteroid, like even Comet Atlas and even 1998 OR2, although you could see those moving from image to image, those are really too slow for using NeoTracker because the encoders are too coarse for that. They'll jerk a little bit in position. They'll jump from position to position, and you'll see really obvious encoder resolution limits. When you're tracking at higher speeds, you don't see that. It doesn't show up. You can see how quickly the coordinates are changing on this DOS window in the background there, that command prompt. So when it's changing real quick like that, that's when NeoTracker is at its best, at least for the LX200 Classic. Oh, nope, not 3000. 2000. And the interface is a little goofy because you would think that when you type in the text box it would automatically take the new value, and it doesn't. It's not how I built it. I built it to grab the new value only when the button is pressed next to the box. You can manually type in a value to offset it by a certain number of arc seconds, but you actually have to push the button for it to take that new value. And that, although that seems like a glitch or a goof, I've actually found it a useful feature because I will fat thumb it constantly when I'm in the dark here, trying to hit the right buttons, and I'll punch in completely the wrong value, and I'm glad it doesn't shoot off in that direction. I want to be able to confirm the value I'm entering before it takes off. So we're at 53 after the hour. Seems like it's getting maybe a little fainter. It's definitely going to be getting lower here. Ion engine. It's practically half a TIE fighter. Yeah. Yeah, we're getting relatively low in the sky here. It'll probably be hitting a tree in a few minutes. Maybe, I don't know, might be able to get 15 more minutes out of it. Yeah, I think they are gonna. Whoa. Whoa. What are you doing? Well, that's gonna be the end of that. Jeez. Dang it. Oh, shoot. Well, we had a deck runaway there. The declination drive went into runaway. Oh. Well, sorry folks, that's going to be the end of BepiColombo for the night. Oh, I just had to emergency shut off the telescope because she started to run away. And I think it's because I'm pretty sure it's because of the cable. My declination cable tab broke a couple weeks back, actually. I noticed it had broken. I don't know how that happened, but nevertheless, it meant that one end of that cable could only sit loosely in the connector plug into the base of the telescope. And so it just got wiggled a bit by the motion of the telescope as it was tracking the probe. And when that happens, if it gets loose and it doesn't make a full connection, the declination drive will just start steering itself in one direction constantly till it kills itself. So I had to go run over to the scope and emergency shut it off, which of course eliminated my alignment and everything else. So I'm unfortunately going to have to be done tonight tracking the probe. But we did get it there for a while, which is cool. So yeah, that's gonna have to do it for this stream. And note to self, next thing I'm gonna have to do is fix that declination cable. Basically it's an Ethernet cable, but it's not with a regular. It's a crossover type. It's not just a crossover type, I guess, but it's the wiring flips over to some extent inside of it, and so it's a custom pinout on that cable. And this is actually a replacement cable that I made at one point. Unfortunately, I don't have the tool for attaching the connector. My dad's got one of those. He helped me make this cable, so I'm gonna have to get one of those and get a new cable made up at some point, or just replace the connector end on it again. Not a big deal. It's an easy fix, but it's just one I thought I could get away with for a while before fixing, because it didn't cause me any problems till just this moment. But I knew eventually, sooner or later, that was going to happen, and I was kind of thankful it didn't happen during an Atlas stream. But it did happen just now, so that's a sign that it's time to actually go ahead and fix that cable. So that's the next repair on this 16-year-old telescope. Never a dull moment. Yeah, exactly. Yeah, I'm glad I could provide some views there of Bepi, and hopefully the telescopes in New Mexico, at the very least, get some nice images of it streaking through, and I can share those in a video later. What would be really cool is if the one in California can also get it at the same time as the scope in New Mexico, but the weather forecast, ooh, yeah, they're closed. California's closed. It's clouded out. New Mexico looks clear though, so my New Mexico scopes will be taking pictures throughout. System resetting. Looks like maybe, well, yeah, it should have already wrapped up. The observations I scheduled on T20, Telescope 20 on the iTelescope network, should have wrapped up by now. It said I had one starting. Oh, I guess maybe it hadn't started yet. Maybe it was going to start a little later. 12:50 a.m. system local time. What is the time over there right now? Oh, okay, it doesn't start for another 50 minutes. All right. So the observations in New Mexico don't occur till a little bit later. Because I got a second email that I thought was the first observation kicking off, but it was actually just a notification. I've got at least 2 telescopes scheduled to observe it in New Mexico, and I got notifications on both of them that the system will be running those observations later. So maybe, just maybe, I can get some astrometry out of that and solve for the orbit using the iTelescope.net images, because the images I took just now, although you could see it moving against the stars, there's not enough stars in any one of those images to be able to reasonably astrometrically solve the image and determine the exact coordinates. So I'll just have to grab the images from iTelescope and see if we can have some fun doing independent orbit determination on Bepi as it leaves the Earth-Moon system, or it swings by Earth. I mean, it's really close to Earth right now. We're talking closest approach, just to give you guys some perspective on it, because I didn't have a chance to do this earlier. They've got it on heavensabove.com. Closest approach to Earth was 19,000 kilometers, according to Heavens Above. And speed at closest approach was 7.5 kilometers per second, 7.596 kilometers per second. So, yeah, pretty close flyby for a gravity assist. And that, it hit the time of closest approach just after midnight here, 24:57 local time, and then it came out of Earth's shadow just a few minutes before I started the webcast at about 1 a.m. So, nifty neato. Well, I'm glad we got to do that, even if I had to have a panic attack at the end to shut off the scope before it collided and killed itself. It's actually, I powered it back up and it's running fine now, so it's not a permanent runaway condition. So that tells me it is the cord. I wiggled the cord until it stopped doing it. So it's just a cable issue. But yeah, that's going to do it for this live stream. So thank you all for coming. Thanks for watching, and I'll hopefully be able to get some images from my telescope and share those in a separate video later on this weekend, as I process all that, and I still have to process the images from my last Comet Atlas webcast. So keep an eye out for those videos this weekend. If you haven't already, consider subscribing, and stay tuned for more in the future. Till next time, clear skies, folks.